Welcome children for the next episode. Now we are going to do the revision of unit motion. There is a remaining part. That is from the revision, the second episode. Here, first of all, we want to know what is the relation of, or what is the use of a graph in the case of motion. We know graph we used in the different fields. For example, in a cricket play, the run rate and over we can plot in the two axes in x and y. Similarly, in our motion, that means a graph gives information about a motion in its simplest way. In a motion, when we consider the use of graph, that graph can be represented with a distance time or velocity time. In the different forms we can represent these quantities in a graph. In these graphs we call the shape of graph as line. That means sometimes it may be straight line, some other times it may be in irregular shape. Now, one question to you that you already know its answer. What kind of graph is used to represent motion of an object? That means to represent motion of an object, we use line graph. What kind of graph we use to represent motion of an object? We use what is a line graph. Now, in the line graph, one quantity that may be distance, speed or velocity in one axis, and how that varies with the time, show time in another axis. Now another question to you, how we can draw a distance time graph? How we can draw a distance time graph? Distance time graph. That means in distance time graph, see, distance is taken in the y-axis and time is taken in the x-axis. Here, appropriate units we choose in this manner. Sometimes it may be 2, 4, 6, 8, 10. Here also 10. 20, 30, 40 in this manner, or 5, 10. We can choose any scale according to the data given. For a uniform motion, that means for a body moving with a uniform speed, if we draw its distance time graph, we get a straight line graph in this manner. For a body moving with a uniform speed, when we draw the line graph of it, we get a straight line graph. We get a straight line graph. If the distance and time plotted in time in x-axis and distance in y-axis, and if the motion is uniform, then the graph is in this manner. What kind of graph? It will be a straight line graph. If the motion is not uniform, see, if the motion that given is not uniform, then the graph here we obtain sometimes that is in this manner maybe. Then we say in this under joining this we get a graph like this. That means it is not a straight line if the motion is not uniform. For uniform motion, the graph is a straight line. Now, one question to you. In a uniform motion, the distance travelled by an object is directly proportional to which quantity? In a uniform motion, the distance travelled by a body. That means here is the distance here. See the distance. And here the distance is there. This distance is directly proportional to which quantity? In a uniform motion, the distance travelled by a body is directly proportional to time. So, distance directly proportional to time in uniform motion. Distance travelled is directly proportional to time in uniform motion. That you want to remember. Now another question, can we use distance time graph to find the speed of an object? This is the distance time graph. Distance and time graph. Can we use? Is it possible to use this graph to find speed of this object? Answer yes or no. What is your answer? By using this graph, there is a distance and time. Is it possible to find speed of the object? Answer from your side, is it yes or no? Okay, it is yes. Then how? Consider any 2 points. Suppose this one point A, this another point B. Draw a line parallel to this and here another line. Suppose this point is C. Let this BC represent, BC is equal to distance, and there is a distance that is equal to what is S2 minus S1. Here the S2 minus S1, it is the distance, and SC is the time that is equal to T2 minus T1. That means here the time T1, here the time T2. This distance is here S1 and this S2. This straight line distance that is also equal to displacement. So this here BC distance and AC time interval. So speed is equal to, we know distance by time, that is S2 minus S1 by T2 minus T1. Here speed is equal to what is S2 minus S1 divided by T2 minus T1. Now the question that asked to you, which question that means can we use distance time graph to find speed of an object? Answer is we got the speed of the object, that is s2 minus s1 by t2 minus t1 from the graph. Okay. Now another question, in a non-uniform motion. In a non-uniform motion, what is the shape of a graph? Is it a straight line or not? What is the answer for this? Check here. Is it a straight line? No, it is not a straight line. In the case of non-uniform motion, what the graph which we obtain, that means the line graph which we obtain is not a straight line. Now another question to you. Wait. How the graph look like in an object moving with a uniform velocity? That is, when you are drawing velocity time graph, that is time along the x-axis and velocity along the y-axis. Here suppose an object moving with a uniform velocity. That question is this, how the graph look like in an object moving with a uniform velocity. In an object moving with a uniform velocity. Suppose a car is moving at a speed of 40 km per hour along a straight road. Suppose a car is moving at a speed of 40 km per hour along a straight road, and its speed is noted after every 5 minutes. Then we got that speed remains same. That is moving along the straight road, moving along a straight road, so that the speed is here velocity. Now we can draw 0, this 5, 10, 15, 20. After every 5 seconds we are noticing this one. And here 10, 20, 30, 40. See, at first observation, when it was started to observe, that means when we started to observe, its speed is 40 km at the time t is equal to 0. Then after 5 seconds again when we observe, it is what is 40. Then after 10 seconds again we notice, 15 seconds also notice, and this way. Then by joining these all points we get a graph which is a straight line. So an object moving with a uniform velocity, if we draw its velocity time graph, we get a straight line graph, and that graph here, what is parallel to time axis. Here we got the graph. It is a straight line which is parallel to the time axis. Now, this graph, from this graph, is it possible to find the distance traveled, otherwise displacement? Is it possible? Consider any 2 points in the graph. Suppose this is a point A and this another point B. Now drawn lines 5, 15, and this is C, D. Now see, here velocity is uniform and time. We know for a body moving with a uniform speed, the distance traveled is given by what? It's a velocity into time. Here the velocity is in this time interval. Suppose this time interval is t1 and this is t2, and velocity c. Here AC is the what? AC is the uniform velocity and CD is the time interval. So displacement here is equal to what is AC into CD. That is equal to AC is the uniform speed here 40 km per hour, and this CD is the time interval, that is T2 minus T1. Here otherwise 15 minus 5, 10. That is equal to 40 into T2 minus T1. Actually this gives this is a rectangle. So area of this rectangle represent displacement. Area of this portion, this shaded portion, gives the displacement within the time interval T2 and T1. So, what is the importance of velocity time graph? Velocity time graph gives displacement. Area under velocity time graph and time axis gives area under the velocity time graph and time axis gives displacement. So the importance is that we can find out displacement from the velocity time graph area, which is coming under what is velocity time graph and time axis. Velocity time graph is this one, and time axis this one, and the area coming in between this gives displacement. That is the importance of what? Velocity time graph. That is, velocity time graph gives this value to us. Now, the question to you: is the height of the graph changes with the time? Question is this one. Height of this graph changes with the time. See, at the time when it is 5 seconds, the height is where 40, and it is at 10. Time when 10, height is 40 itself. Here also height. Now the question to you is: the height of the graph changes here? Answer: no. Then how is the graph look like? The graph is a straight line parallel to the parallel to the time axis. Now another question to you: can we find the displacement of an object moving with a uniform velocity from velocity time graph? What is your answer? Can we find displacement of an object moving with a uniform velocity from velocity time graph? Yes, it is possible. How we know? In the case of a body moving with a uniform velocity, its displacement is equal to velocity into time, and that is equal to what is here area under velocity time graph and the time axis. Now another question to you: can we study about the uniform velocity Can we study about uniformly accelerated motion by using velocity time graph? Can we study the properties of a uniformly accelerated motion by using velocity time graph? See, in the case of a uniformly accelerated motion, in the case of a uniformly accelerated motion, see, here time, here velocity. Uniformly accelerated motion means its velocity changing at the same rate. That means suppose in the first second if its velocity increase to, then again that means at the same amount it will be increasing. For example, when a body falls downward or under free fall, it is uniformly accelerated. That means after every second its velocity increases by 9.8 meter per second. So in the case of a uniformly accelerated motion, if we draw the graph, then the graph we get like this with velocity and the time. If we draw the graph of a body moving with a uniform acceleration, a body moving with a uniform acceleration. How is the graph we got? The graph is a straight line. The graph is a straight line. Can we find the acceleration from this C? Any 2 points in the graph A and B. Suppose we are drawing a line parallel to the velocity and this will come in this way, and another line parallel to this, and these two meeting at the point C. From this we can find out what is acceleration. We can find out acceleration of that body. Acceleration is actually what? Change in velocity by time. Here change in velocity is what is BC. And time here that is AC. That is acceleration is equal to BC by acceleration is equal to what is BC by A. In this way we can find out acceleration of this object that is moving with a uniform acceleration. Now the question that I asked to you, can we study about uniformly accelerated motion by using velocity time graph? Yes, it is possible. We can study. And what about the area under this velocity time graph? Suppose in this interval, the area is coming this and this. What actually this shows? Area under this velocity time graph in between the time intervals, suppose t1 and t2, what this area shows? In between the time interval t1 and t2, this is the velocity time graph. The area between the velocity time graph and time axis, what it actually represents. Can you say? You know it? It represents what is the? It represents displacement. It actually represents displacement. So from this we get again displacement. Then how we can find this displacement? See, area of this rectangle and area of this triangle. Area of this rectangle, we know area of the rectangle is equal to A, C, B is the triangle, and D, E. A, D, E, C is the rectangle. Area of the rectangle is equal to, that is equal to A, D into D, E, or A, D into A, C. In this way we can find out the area of this rectangle. That is area of the rectangle is length into breadth. And what about the area of this triangle? We know area of the triangle is equal to half base into height. Here base is AC. So half into AC into height, what is BC. In this way we can find out what is displacement. That means displacement is given by area of this rectangle plus area of this triangle. So what actually this area shows? It shows displacement. Suppose if the body is not moving with the uniform acceleration. If the body is not moving with the uniform acceleration, then its velocity time graph, if we draw, not the uniform acceleration, then its time and velocity graph may be like this. That means it is not a straight line. It is not a straight line. If the velocity gradually decreases, that means uniformly accelerating, its velocity is gradually decreasing, then uniformly decreasing, then its graph is this way. For a body moving with a uniform acceleration, but that velocity is decreasing at the same rate, then the graph of velocity and time will be in this way. So we can draw the graph of body moving with a uniform acceleration. When we draw its graph with the velocity and the time, we get a straight line graph. If it is not moving with a uniform acceleration, then the graph looks like this. That means not in the steady form. Now see, we got different types of graph. Actually, what is graph? Graph is the representation of given data in the form of a picture. Graph is the representation of given data in the form of a picture. Here we draw graph of motion with the distance and time and with the velocity and time. We consider here what kind of graph? We considered it is with a line graph. Now from this graph we can obtain some equations of motion. See, a body moving along a straight line with a uniform acceleration, and if it starts with a velocity u and it is accelerated at the rate a, then after a time t its velocity becomes v. Then these quantities we can represent by the equation v equal to u plus at. V is equal to u plus at. Here v is the final velocity. U initial velocity. A uniform acceleration. Now v is equal to u plus at is one of the equations of motion. This represents with the velocity time relation. This is the relation. What is a velocity? First one is a velocity time relation. V is equal to u plus at. It is the velocity time relation. Now, if this body moving with an initial velocity u is accelerated at the rate a, and after a time t it produces a displacement, or it moves along a straight line a distance x, then s equal to ut plus half a t square. Then that displacement s equal to ut plus half a t square. This is the second relation which is connected with the position and time. Position time relation. That is s equal to ut plus half at square is the position time relation. Now, here s is the position, that is the displacement made. Then another relation is this. The second one is the position time relation, and third one is v square minus u square is equal to 2as. Here this relation v square minus u square is equal to a is the velocity and position. Velocity these are the three equations of motion, which are the v equal to u plus at, s equal to ut plus half at square, and v square minus u square is equal to 2as. This we can write in this way also. V square is equal to u square plus 2as. In this way also we can write. This is the velocity and position connecting relation. These three are the equations of motion that you want to study about it. That means here is terms here given: v final, u initial, a uniform acceleration this. Now these equations of motion we can also obtain from using velocity time graph of a body moving with a uniform acceleration. See, this is the time, this is the velocity of a body moving with a uniform acceleration. Now we can consider a body moving with a uniform acceleration, and for that, suppose its initial speed u is not 0, like this. A graph AB represents this one. Then OA is the initial velocity u, and BC final velocity, and AD or OC is the time. Now we know the velocity under this graph, that is velocity time graph and the time axis that shows the displacement. Now we are going to find within this time how much is the displacement. First it starts with the initial velocity. Now this is the change in velocity. Here change in velocity is equal to initial velocity u and final velocity is bc. So bd is equal to, from this relation bd is equal to what? bc minus bd, this much is equal to bc minus oa or cd. Now BD from this relation, what? BD is equal to BC is the final velocity v, and CD is equal to what? Initial velocity u. So BD is equal to v minus u. BD is equal to v minus u. Also, we know the time interval, that is OC, and this OA is the what actually? Initial velocity, and from this AD is equal to OC. We know acceleration A is equal to actually change in velocity, that is v minus u by the time, that is OC, that is equal to t. So A is equal to v minus u by t. On cross multiply, what we get? V minus u is equal to A into t. V minus u is equal to A into t, or V is equal to what? V is equal to, from this relation, V is equal to u plus a t. This is the first equation of motion that we obtained from the velocity time graph of a body moving with a uniform acceleration. Velocity time graph of a body moving with a uniform acceleration v is equal to u plus at. Now we want to get these two relations that we can discuss later on with this all we can conclude this class. Thanks.